It dominates the wall of nearly every living room in the modern world. That sleek, paper-thin black rectangle that comes alive with movies, sports, and entire universes of streaming content the moment you press a button. The LED TV. Just 30 years ago, televisions were heavy, bulky boxes weighing dozens of pounds, with curved glass screens and limited resolution. Today, a 65-inch flat-panel television is thinner than a stack of magazines, sharper than the human eye can fully resolve, and capable of displaying over 1 billion colors in extraordinary detail. The global television industry ships more than 200 million units every single year, and behind that staggering number is one of the most technologically advanced manufacturing processes in all of consumer electronics. But here is what almost nobody binge-watching their favorite series ever stops to consider. That flat panel hanging on your wall is one of the most precisely engineered objects you will ever own. It contains millions upon millions of microscopic pixels, each one made up of even smaller subpixels, illuminated by carefully engineered light-emitting diodes, all coordinated by sophisticated processors that interpret incoming signals and translate them into images at 60 or more times per second. Building one of these televisions requires factories cleaner than hospital operating rooms, robotic assembly with micrometer precision, and a global supply chain that pulls together components from dozens of countries. The TV in your living room is not just a screen, it is a triumph of material science, optics, semiconductor engineering, and industrial design, all condensed into something thin enough to disappear against the wall. Stay with me until the end, because what you're about to discover will change the way you look at the most beloved screen in your home. Right here on Stories Behind Everything. The story of the modern flat-panel television is a story of extraordinary scientific progress, compressed into just a few decades. For most of the 20th century, televisions used cathode ray tube technology, a thick glass vacuum tube in which a beam of electrons was fired at a phosphor-coated screen, lighting up pixels one line at a time. CRT televisions could weigh well over 100 pounds, took up entire entertainment centers, and were limited in size by the physics of their glass tubes. The dream of a flat television had existed for decades, but seemed almost impossibly far away. The breakthrough came with the development of the liquid crystal display, or LCD, in the latter half of the 20th century. Liquid crystals are an extraordinary substance, a state of matter that flows like a liquid, but whose molecules can be oriented like crystals. When electricity is applied, they twist and align, controlling how light passes through them. By placing millions of tiny liquid crystal cells in a grid, and combining them with color filters, engineers created a way to build flat displays. The first LCDs were used in calculators and watches, but as the technology matured through the 1990s and 2000s, it became possible to make them larger, sharper, and brighter. Then came the next leap: LEDs, or light-emitting diodes, replacing the older fluorescent backlighting that LCD panels had originally used. LEDs are smaller, far more efficient, generate less heat, and allow for vastly thinner panels and richer images. The term LED TV technically refers to an LCD television backlit by LEDs, and this technology became the dominant standard, eventually evolving into the advanced variants that fill stores today, including OLED and QLED, which push the technology even further. To understand how an LED TV is made, you must first understand what is actually inside it. A flat-panel television is a sandwich of carefully engineered layers. At the back is the backlight, a thin sheet of LEDs that provides the light for the entire display. In front of the backlight are diffuser sheets, light guide panels, and brightness-enhancing films that spread and shape the light evenly across the screen. Then comes the liquid crystal panel itself, millions of tiny cells arranged in a precise grid, each containing liquid crystals that can be electronically twisted to allow or block light. In front of that are color filters, microscopic red, green, and blue squares that color the light passing through each cell, creating full-color pixels. Polarizing filters control the orientation of the light, and a glass or polymer protective layer covers the entire stack. All of this is housed in a slim frame, connected to circuit boards, processors, power supplies, and the input and output ports that link the television to the world. The most critical and most extraordinary part of TV manufacturing is the production of the LCD panel itself, and this happens in some of the most advanced facilities on Earth. The process begins with enormous sheets of ultra-pure glass, sometimes called mother glass, which can measure several meters across. These massive glass substrates are produced in dedicated factories using a method called the float process or fusion process, creating glass of extraordinary flatness and purity, free of even microscopic defects that would ruin a finished display. The mother glass arrives at the TV factory and enters a clean room, an environment far cleaner than any hospital operating theater, where the air is filtered, humidity controlled, and workers wear full bunny suits to prevent even a single hair or particle of skin from contaminating the surfaces. Within these clean rooms, the glass undergoes a series of remarkable processes borrowed from the world of semiconductor manufacturing. Thin films of metal and other materials are deposited onto the glass surface through processes like sputtering and chemical vapor deposition, building up the patterns of electrodes and thin-film transistors that will eventually control each individual pixel. Layer by layer, the patterns become more intricate. Photolithography is used to create incredibly precise patterns on the glass. Light is shone through masks onto a photosensitive coating, exposing patterns that are then chemically developed and etched into the underlying layers. This process is repeated many times, building up the matrix of millions of tiny transistors that will control the pixels. A modern 4K television contains over 8 million pixels, and each pixel is controlled by its own dedicated transistor, meaning that the panel of a typical TV contains tens of millions of microscopic switches, all working in perfect coordination. Once the transistor matrix is complete, the color filter layer is added. This is where the screen gets its color. Microscopic red, green, and blue color filter materials are precisely deposited onto another glass substrate, creating millions of tiny colored squares arranged in a grid pattern. Each set of red, green, and blue subpixels together forms one pixel of the final image. When the two glass substrates, one containing the transistor matrix, the other containing the color filters, are precisely aligned and bonded together, with the liquid crystal material sandwiched between them, the heart of the LCD panel is complete. The alignment must be perfect to within micrometers, because even a slight misalignment would cause color errors visible to the naked eye. The liquid crystal layer is filled into the panel under vacuum, and the panel is sealed shut. Then comes another remarkable step: the polarizing films, which are essential for the liquid crystals to function as light valves, are precisely laminated onto both the front and back of the panel. Each step requires extraordinary cleanliness. A single particle of dust trapped between layers would create a permanent visible defect, an unacceptable flaw in a high-definition image. While the LCD panel is being made, the LED backlight is being prepared separately. Tiny light-emitting diodes, each one a small semiconductor that emits light when current passes through it, are mounted onto strips or sheets that will sit behind the LCD panel. In edge-lit designs, LEDs are placed along the edges of the panel, with light guides distributing their light across the entire screen. In direct-lit and full-array designs, hundreds or even thousands of LEDs are arranged across the entire back of the screen, allowing for advanced features like local dimming, where different zones of the screen can be brightened or darkened independently to produce deeper blacks and richer contrast. The completed LCD panel and the LED backlight assembly are then brought together along with the other layers, diffusers, brightness-enhancing films, light guides, and stacked into the precise sandwich that forms the display. This entire assembly is then mounted into the television's frame, often surprisingly slim, designed to be visually elegant while still housing all the necessary components. But a television is far more than just a display. The brain of the TV is its main board, a sophisticated circuit board packed with processors, memory chips, and tuners that handle every signal coming into the television and convert it into the appropriate output for the screen. Modern TVs incorporate powerful image processors that perform incredible amounts of computation in real time, upscaling lower resolution content to higher resolutions, reducing motion blur, enhancing colors, optimizing brightness scene by scene, and running smart TV operating systems with their apps, streaming services, and voice assistants. The main board is connected to the panel by delicate ribbon cables, alongside the power supply board, which converts incoming household electricity into the various voltages the television needs, and the speaker components that produce the sound. Assembly of all these parts happens on highly automated assembly lines, often with robotic arms placing components with absolute precision. Each television begins as a frame, into which the panel assembly is mounted. Circuit boards are then installed, ribbon cables connected, speakers placed, and the back cover attached. The set is then powered on for the first time in a test station, where it goes through an intensive series of automated tests. Every pixel of the display is checked for defects, dead pixels, stuck pixels, or color irregularities. The processor and software are loaded and verified. All inputs and outputs are tested. The television must pass every single one of these tests before being approved for the final stages. Final quality control is rigorous. Color accuracy is measured with specialized instruments that verify the display reproduces colors precisely according to international standards. Brightness uniformity is checked across the entire screen. Sound is tested. Wireless connectivity, including Wi-Fi and Bluetooth, is verified. Some manufacturers subject samples from each production batch to even more demanding testing, environmental tests, drop tests, and long-duration burn-in tests to ensure the TVs will perform reliably for years. Packaging is the final stage. Each finished television is carefully cleaned, fitted with protective films over the screen, accompanied by a remote control, cables, and documentation, and packed into custom-designed boxes engineered to absorb the shocks of shipping. From there, they travel through global logistics networks to retailers, online warehouses, and ultimately to the homes of consumers around the world. That television on your wall represents an extraordinary convergence of disciplines and technologies. It is glass made flatter than the surface of a still lake. It is liquid crystals choreographed at the molecular level. It is semiconductors fabricated with photolithography borrowed from the chip industry. It is LEDs developed through decades of materials science, processors more powerful than the computers that sent humans to the moon, and a global supply chain that connects rare earth mines, semiconductor foundries, glass plants, and final assembly factories across continents. All of it condensed into a flat black rectangle so thin and elegant that we barely notice it when it is turned off. Every time you turn on your television, you are witnessing the result of one of the most remarkable industrial and scientific achievements of the modern era. From the cathode ray tubes of the 20th century to the impossibly thin flat panels of today. The journey of the television is a story of relentless innovation, and the screen on your wall tonight is the latest chapter in that story. The objects that have changed our lives most profoundly are often the ones we take most for granted, and the modern television, flat, brilliant, and endlessly captivating, is one of the most quietly extraordinary inventions of our time. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you proper recognition for your contribution. Thank you for joining us on this exploration through stories behind everything. Don't forget to like, subscribe, and stay tuned for more stories discovered through the smallest details.